It is time for the mid-latitude cyclone. Welcome to Earth Science. It's time to take all of the stuff you did on here and mash it together into one map to say what goes on with these low pressure systems as they work their way through uh, the United States, as they work their way through the place that I live. Let's go back. I still have this open. I mean, this is such a good view of one. So we're gonna like look at this and we'll come back to it. Again, cold air is coming down from the north, warm air is coming up from the south, and I can very clearly see that boundary right there between the two. That's what we're gonna call a front. This is a very nice, well-developed mid-latitude cyclone. There's none really happening in the states right now. These areas get a little bit weird because of the mountains, and this one's kind of been pretty beat up, run its course. So let's look at it. What is a mid-latitude cyclone? And where did I put these notes? Here we go. So you got a low. Winds blow from high to low. Note we don't have to do one of these pages for highs. Again, if you're a meteorologist, high, it's clear, job done. Lows, there's more to it. So what the lows are going to do is pull air towards it, but the Coriolis thing makes it curve and go around it in a counterclockwise direction. So here's where we're going to start. We got a lot to do on here. Try to follow as closely as you can. We got cold air coming down from the north, which we're going to call continental polar. Now, in the case of what I was showing you on that website, I'd more likely say this is maritime polar. It's coming down off of oceans. But the ones that affect us up here in New York State would be coming off of the continents, continental polar. Where that is like its leading edge, where it's punching through, where we drew this thing right here called the front, what you got to do now is really picture that this drawing here is the same as this drawing here. Only in this one, we're looking from the side. In the other one, it's like, what if we were up on top looking down from some kind of very high air balloon or satellite or whatever? Looking down, here's the cold air moving across the surface, and it gets to where its leading edge is called a cold front. Now, these symbols are available for you right there in the reference table anytime you want it, right here in your cheat sheets for the labs. You can't use the cheat sheet on the test, unfortunately. But here we go. The cold front has blue. It tends to be blue. That doesn't indicate in the reference tables because it's printed in black and white. But it definitely has these like triangles. That's the symbol we use for a cold front. Okay. Meantime, there's other air that I'm going to go back to black for. There's other air being pulled up from the south. And again, it is being sucked towards that low because winds blow from high to low. And that is going to be your warm, wet air coming out of the for us generally coming out of the Gulf of Mexico, maritime tropical. And again, it's a whole lot of air and it's moving its way this way. And again, that's what this drawing right here is. Here's a whole lot of air and it's moving that way. And as it happens, there's the front. And we'll think about the precipitation in just a minute when we want to complicate life. But the way this works is that it comes off the low, and the warm front symbol is like a semicircle. Okay, there you go. That right there, even if you don't have the CP and MT, this right here is what mid-latitude cyclones look like. I promise a question, and it'll be on the lab for sure, and then maybe even on the test. That will be, what does a mid-latitude cyclone look like? And the regents will do silly things like they'll switch the cold and the warm. That's not how it works. They'll make it go the other way so that it's going clockwise. That's not how it works. This is how it works. It doesn't change up. It can progress. The cold front can go fast enough that it rams right into the warm fronts. That's when you get this weird thing called an occlusion right there. But we're not really even going to worry about that because it's very rarely brought up on the test. And all it would be is identify that symbol. It's an occluded front. This is what your mid-latitude cyclone will look like, okay? Over here, let's think about our winds and bring what we learned when we did station models to the party. These are going to be generally northwest winds. Yes, we name winds for where they come from. These are generally going to be southwest winds. Again, we name winds for where they come from. This whole low is caught in the wind belt where we live. Remember wind belts? That thing, it's caught in the wind belt where we live. We live in the southwesterlies, so this whole pressure system will be blowing that way while this air is trying to swing around it in this counterclockwise direction. What else can we add here? What else might definitely be in your lab? The idea that, okay, right on the front, you've got very tall clouds, you've got storms, quick violent storms that are happening, boom, right there. So if I were a weatherman and I were looking at this, I would say, here's where I would expect storms. It tends to be in green. Since you're on the computer, you can do it in green. I would expect to see storms right along the front in a very narrow band like that. Hey, let's use symbols from the reference tables. Let's make life complicated. Remember this one? Thunderstorms, rain, maybe hail. Hail is the triangle, right? See, I don't even memorize this stuff. You got to use your reference tables. So, rain, thunderstorms, hail, all possibilities. I'm just going to put them at the bottom. All possibilities along that quick cold front storm. Because as it happens, as this cold air blows in, it lifts this warmer air right up off the surface of the earth and boom, dumps its moisture right back on top. Now let's do the warm front. The warm front, here's the air moving in, but it gets raised aloft and out ahead, you get your rain showers. So it's on the surface here, it's coming up, but at that place on the ground, that's where it's going to come up off of this piece of paper and work its way up to here, but aloft, up in the atmosphere. So out here, maybe, is where you would get your rain showers. So let's look that up. I think it's the dot with that kind of elongated triangle below it. Notice how it's like a bigger region. You don't have to draw those if you don't want. But I'm saying this is like a bigger region. This is like on the scale of maybe a day full of rain showers versus this being like comes through and gives you a quick thunderstorm and then you're done. The low itself tends to be rainy and cloudy. Remember this? Where the low is, you form clouds. So I'd say all of that is likely to have clouds too. So this right here, if you step back and look at it, is what a mid-latitude cyclone looks like. I'd say type it into Google Images. Let's do it. Let's do it together. See if just to show that I'm not making this up. I mean, these diagrams are all going to kind of look the same. They can get more advanced and be difficult. That's if you go to the southern hemisphere. If you go to the southern hemisphere, everything switches around. Doesn't that get complicated? But all of these other ones are looking just about right for the northern hemisphere. Okay, so Mr. F's not making this stuff up. This isn't just me. This is what mid-latitude cyclones look like. We didn't write a ton on here, but it's a ton information-wise because you had to like think about all of this, and all of this, and combine it to say, here's on a weather map what happens. So should you run into a weather map analysis lab, this is the meat and potatoes. If there's a low happening, can we figure out where the cold front is, where the warm front is, and where it's raining? If you can do that, hint, hint, copy this map, you're going to be in okay shape. All right. I'm doing a much simpler version of it this year than I usually do. So you're in luck there. And you can do it. You're smart folks. Keep up the fight. Thanks for fighting through all these videos. We do have one more to go, but you're going to make it. All right. Good luck, everybody.